Imagine a world where the ocean floor is no longer a mystery, where every movement beneath the waves can be tracked, recorded, and analyzed in real time. That world is here, and it's powered by underwater drones, the Navy's secret weapon that's changing the future of maritime warfare and exploration. These sleek, high-tech machines are rewriting the rules of how navies operate beneath the surface, combining stealth, intelligence, and precision in ways that were once only seen in science fiction. At first glance, an underwater drone looks deceptively simple, almost like a torpedo or a compact submarine. But beneath that streamlined body lies a powerful network of sensors, propulsion systems, and AI-driven software capable of executing missions completely autonomously. The design focuses on hydrodynamic efficiency, allowing the drone to glide through dense ocean currents with minimal resistance. Built from lightweight composite materials and corrosion-resistant alloys, it can withstand extreme pressure at depths where light barely reaches. What truly sets these drones apart is their versatility. They aren't just tools for surveillance, they're multi-role platforms. They can perform reconnaissance, detect mines, track enemy submarines, and even deliver small payloads or communication relays. Some variants are equipped with sonar arrays so advanced they can map the ocean floor in 3D, identifying objects as small as a helmet in pitch-black darkness. Others are fitted with high-resolution cameras that transmit crystal-clear visuals back to command ships, even in murky waters. Performance-wise, the numbers are staggering. The latest generation of naval drones can travel hundreds of miles on a single charge, powered by next-gen lithium or hydrogen fuel cells. Their propulsion systems are nearly silent, using magnetically driven thrusters that eliminate the traditional noise associated with marine engines. This near-silent operation gives them a huge tactical advantage. They can approach enemy waters, gather intelligence, and return without ever being detected by sonar. The AI on board can process thousands of data points per second, identifying ship signatures, analyzing acoustic patterns, and predicting enemy movement patterns long before human operators could. Communication underwater has always been one of the biggest challenges in naval operations. Radio waves don't travel well through water, which means drones rely on advanced acoustic communication systems. These drones can send encrypted signals over long distances, forming what's called an underwater mesh network. This allows multiple drones to work together, sharing data instantly and creating a coordinated grid of surveillance. It's like having an invisible net cast across the ocean, detecting every disturbance or foreign object that passes through. The design philosophy behind these machines isn't just about power, it's about adaptability. Many of them are modular, meaning the Navy can swap out sensors, cameras, or weapon systems depending on the mission. If a drone is needed for mine detection, it can be equipped with electromagnetic scanners. If it's needed for search and rescue, it can carry sonar beacons and flotation devices. That modularity makes them a cost-effective solution compared to deploying full-size submarines or ships for specialized missions. Another remarkable aspect is their endurance. Some models can stay underwater for months, patrolling vast stretches of ocean without human intervention. They rely on automated docking stations placed strategically across the seafloor, or floating buoys that recharge and upload data. This network infrastructure allows the Navy to maintain a constant presence underwater, essentially creating a digital ocean watchtower system. From a defense perspective, underwater drones serve as silent sentinels. They can monitor enemy movements, plant sensors along critical routes, and even act as decoys to confuse hostile sonar systems. They can also gather environmental data, measure ocean salinity, and study undersea conditions, all valuable information for both military and scientific use. The control systems are equally impressive. Operators can issue commands from thousands of miles away, using secure satellite uplinks once the drones surface. When submerged, they navigate autonomously using inertial navigation and sonar mapping. If they lose communication, onboard AI ensures they complete the mission or safely return to a rendezvous point. At a level of independence that drastically reduces the risks to human crews. Safety and maintenance have also evolved. The drones use self-diagnosing systems that constantly check for damage or malfunctions. If a fault is detected, it can either reroute functions or surface automatically for recovery. Maintenance teams can perform modular repairs, replacing damaged sections without dismantling the entire unit, ensuring rapid turnaround times for redeployment. One of the more futuristic developments in these drones is the integration of swarm intelligence. Imagine dozens of underwater drones working in perfect harmony, mapping, patrolling, and defending large territories as a single collective unit. They share information in real time, adapt to changing conditions, and can even make coordinated tactical decisions without direct human input. With growing geopolitical tensions and the increasing importance of securing undersea cables, trade routes, and maritime borders, these underwater drones are becoming indispensable assets. They extend the Navy's reach into territories that were once inaccessible or too dangerous for manned missions. Every new generation pushes the boundaries of what's possible beneath the waves, combining cutting-edge robotics, AI, and engineering to maintain dominance in one of the most unforgiving environments on Earth.